Whoa.
And we're back. And it's COMP228, and it's week 1, lesson 1, part 4. And if you notice, I'm live on Hangouts on Air. And if you want to go to YouTube, my YouTube channel, you'll see a live link under events. There should be a live link there if you want to follow along. It's also on Hangouts. But if you go there, you'll be able to see me. There's going to be a bit of a delay. I need a monitor, so if one of you want to go on it and check it out so I can see what I can see, like over there, like one of your machines, then I can see what I'm, kind of a reflection of what I'm seeing. Let me actually, if you guys let me know what it looks like. So if you go to youtube.com, right, / you good? Everything good? Okay, good. All right, so this is what it's going to look like. I'm going to be recording my screen, right? And the way to go is you're going to go to youtube.com / my last name. So it's going to be like this, my first initial last name. So it's going to be this. And if you notice here, there's going to be this crazy what to watch, right? It won't be this. There'll probably be some kind of other thing. This is as me. I want to see it as a new visitor. And if you go as a new visitor, you'll see this, right? So if you go here, COMP228 lesson 1 part 4, if you click on this, you should be able to see me with a bit of a delay. And that's what it'll look like when I'm recording, when I'm actually physically broadcasting up there, right? Now, I don't know what it's like to get chats going on because I don't know how I can do chatting and at the same time I'm doing screen sharing. And don't know. Don't do it, man. Don't chat with me, man. Come on. You're killing me, right? All right. And let's see if I'm actually getting it. Hold on a second. If I pull this, I'm afraid. I'm very afraid. What's going to happen if I pull the chat up? You're going to see like a million things. Ah, it's crazy. Let's see if I can pull up the, well, I'm doing a chat part up, and I can reduce this, the group chat. And I don't know if I'm seeing anything yet. I don't see anything. But just curious as to what it's going to look like. Right? Did you send it up?
Yeah.
Huh? And it'd be nice if I could just, just get rid of this and just separate the group chat. But anyways, can't do it right now. So let's. Is it? Comments. A comment. Okay. There's no comments here. All right. So sorry for the technical difficulties, but I am broadcasting. We are about, I believe, 5 or 10 seconds behind, just from a delay perspective, so you guys can stream. What we talked about last time was this hello world thing example. So when we go up on Eclipse here without the funny business, if I press play on my console, what I'm going to get is this hello world. And when we really talked about this is really an output. That's what this thing is right here that we're looking at, right? So we have an output going on. We're telling this string literal is being output to my console. Okay, it's pretty much very simple. And when I have a print line, it's like saying write line. Similarly, if I have multiple print lines, right? So if I kind of copy and paste here, right? So here's my copy and paste scenario. And if I also run this, now when I run, I'll automatically save my class here. If you notice, I got 2 hello worlds, right? That's what it looks like. So this is my console. If I bring it up, you can see that there's 2 hello worlds, one on top of the other, just like it would be 2 write lines. Okay. Now here's the difference. If I change this print line, print ln to a print, right? If I do one of those, and now I run it, I get the same thing that you would expect. Hello world, as if it was a console.write in C#, and a print line, which is the, with a new line, a variable, a new line character added in. So there's 2. The print line is actually a print with a new line character, break escape character. Let's try this out. So if I was going to go into my string literal, that's what this is, right? And put a \n, do it properly, \n, right? And save, and then run it, it should give me the same effect as doing 2 write lines or 2 print lines. See, print line with a print with a \n, or a print line without a \n just goes to the next line. Okay. Output is what we talked about earlier today. Okay. What I'd like to do though is cover some of the stuff we're going to talk about in our presentation. I'm going to blow through it pretty quickly, especially for Chapter 1, because Chapter 1 is really a review of everything computer, internet, and blah, blah, blah related. There's only a couple things I want you to look at. I'm going to go right to those pieces in the presentation. So please bear with me as I do this. By the way, both presentations, Part 1 and Part 2 now, are up on eCentennial. You can always look at them if you don't want to look at me. Okay? Here's Part 1 for PowerPoint. And I'm just going to maximize this. Hopefully it won't kill my... by the way, if people who are the watchers, if the watchers see something that shouldn't be, what do you see? Tell me if you're seeing both screens. If you're seeing both screens, this is bad, right? You should be only seeing just the slideshow, right? Which is just this. Yeah. All right. And hopefully you should not be seeing me. If you see me, that's a bad thing. No. I don't want to see me, all right? Okay. So again, I got my slideshow, and again, we're using this book here, Java How to Program 10th edition with early objects from Deedle and Deedle. It's a father, son, daughter team, kind of thing that kind of do their books. They've been doing it for many, many years. They're, like I said earlier today when we were talking about it, not the friendliest of books to read. If it's not an easy read, it's not like something you'd sit there and go, I want to read this before bedtime. All right, it's not one of those. It's one of those ones where you go, this is a manual, I'm going to skip through, read the sections that I need, and not read the other stuff, right? That's what you're going to do. And in our case, because we've already done C#, there's no point in really doing some of the initial stuff again. Part 1, week 1, Part 1 is really Chapter 1 from the book, and in where we kind of look at things like learn about the exciting recent developments in the computer field, right? We're not going to do that. And we're also not going to look at things like different language, object orientation, that kind of stuff. You should know all those things already. It's there as a reference card if you want to look at it. If you haven't looked at, if you're rusty from the summer, you weren't here in the summer somehow, you took a work term or something, and you forgot, this is a great little reference card. I'm not going to read it though. All right, so let's get through it. Again, Java. I'll read the stuff that pertains to Java. So Java is one of the world's most widely used computer languages. Like I said earlier today, I would say it's probably the most important language if you want to make money. Okay, if you want to make money, learn Java, right? It's a great language. You learn how to do stuff with Android. It's very versatile. It's open source. It's a good language to learn, okay? This is interesting. Enterprise desktops, 97% of enterprise desktops, 89% of PC desktops, 3 billion devices, and 100% of all Blu-ray disc players run Java. Sure. A few editions. There's Java Standard Edition, right, which is the edition we're going to be accessing, right? And that's when I see editions, think about Java as a collection of libraries of objects that we're going to be using when we do our coding, okay? So don't think about Java, when you look at a programming language like C#, is there a version to the C# programming language that we have right now? Well, yeah, it's the version that's running on your Visual Studio 2013, 2015, whatever it's going to be you're using, right? And it's probably, it's the latest version of C#. We don't know what version it is. If you don't know what version it is, it's not important because it's proprietary. Because it's being run by Microsoft, it's not really that important for you to know the version. However, on the Java side, it's really important to know the version you're running because there are version differences between Java 8, Java 7, Java 6, and so on. We're using Java 8, so that means 1.8 when it comes to what we saw this morning, okay? One thing that it says that they do add is functional programming. We may get to it in this session, in this semester. A couple of other editions that exist is Java Enterprise and also Java Micro Edition, those two editions, right? Java Enterprise really geared towards large-scale enterprise. If you're going to do Java in the enterprise, you'd learn Java EE. There's some other things you can do there, especially when it comes to making very secure web-based applications. You're going to use Java Enterprise, right? Can you see me, or are you seeing what are you seeing right now? You seeing the PowerPoint presentation or me? Because this would be bad if you're seeing me, right? This is the problem that I had last time, right? I want you to see the PowerPoint presentation. Seeing me is a bad thing, right? Now let's see what happened. Hi, my name is, yeah. It's just weird. Yeah, so let's go back to, maybe I can do this with this one. I don't know how this looks to you, but hopefully it'll just kill the whole idea of the presentation thing going on. And yeah, you're going to need a bit of a shimmy shake down. before it goes. Thank you for that. That's what I needed, right? And you're gonna see me. It's like me watching me in the thing, which is kind of cool and not, you know. I guess if I had better lighting and a different angle instead of this thing in my eyes, it might not be so bad. But for now, you know, it looks like. Let's see if it actually changes. Did it change? Or am I still seeing?
It's not. It's not.
Oh, no.
It's a fix.
It changed for me.
Yay, with black bars. Okay. So I apologize for the delay, guys. This is going to be a bit of learning. And it's back to this. Bear with it, bear with it, bear with it. Right? You're still, looks like you're seeing the same thing over and over again. Look, I'm just, you're like way behind. Right? How about you, Tyler? What are you seeing? Black? Black? Really?
I see the picture.
Yeah.
That sucks. Let's go back to this way. This might be the best way to do it, right? Yeah, I know. It's trying to make so we can do the broadcast thing so it's not so bad. All right, how about that? Is that better? This guy's still articulating, eh? The guy over there, he's still doing one of these, right? Are you seeing me or no? Stop sharing. I'm doing a screen share, so you should be seeing this right now. That's good. Okay. It's just really delayed, huh? Oh, go back to this.
Yeah.
Okay, good. All right. So let's go back to 2 editions I talked about. Micro edition really runs on smartwatches and other things. You know what? They think the micro edition of Java will be used for the Internet of Things, which is a big thing that's coming out these days. Things like running your toaster and your refrigerator, maybe running the implant in your eye. You know, all kinds of stuff are going to happen one day. I know I'm saying that kind of as a joke, but truly, you never know where Java is going to run tomorrow. And that's the great thing about Java. It's everywhere. I'm not going to talk too much about hardware and software requirements. This is the skip part. And same thing with Moore's Law. If you don't know Moore's Law, how things are continually improving or increasing every 6 months or whatever. And they say every year or two. It's not really a year or two. Right now, it's kind of like every 6 months, things are doubling more and more. Also, same thing with computer organization and how things are organized from a memory unit to central processing unit to all this kind of stuff. I'm skipping all that kind of stuff. All right, here's where the stuff gets interesting and applicable to us. Data hierarchy, right? Where we kind of remind you of some terminology again. So again, in data hierarchy, we talk about things like characters, fields, files, and so on, right? And in Java, we start off with the smallest unit, which is the bit. Okay, we can do bitwise addition and subtraction in Java. Same thing we can do in C# and so on. But that's the kind of the smallest unit. Remember, the stuff I'm talking about, only the stuff I'm talking about is the stuff that I'm going to test you on. If I don't talk about it and I skim by it like I just did, guaranteed I'm not going to talk about it on the test. Okay, so don't worry about it. All right, let's go to characters. Here's different kind of characters. There's different decimal digits from 0 to 9, upper letters from A to Z, and lowercase letters from A to Z as well as different symbols. Okay, we're going to skip over to fields. We're going to build it up. So imagine letters build into fields, words, if you will, or bytes, and they can also consist of uppercase and lowercase letters, numbers, and symbols, right? Then a bunch of words form sentences, and they make up something called records, right? Each record is a series of fields that kind of creates, you know, basically a row of data, right? A row of data typically is a record in a database, okay? I want you to think about that. And then from records, we go right into something called files, where you have, or tables, if you will. You have a series of records in a specific file or table, and that's how the you know, the data hierarchy is organized. It's important to understand this because when we come to Java, Java is organized in the way that everything is contained in a class. The class itself describes, the function of the program, and so on. And even though we haven't talked about this too much in C#, it's very much the same. We're just describing it here at a high level in Java. A database then is a collection of tables or files, if you will, right? And some of these tables or files are relational. They're related. One table could be related to the other. Give me an example of how one table can be related to another in a database. Anything.
Could be, for instance, if you maintain a kind of class and another class, you can relate those two classes, or you can have, employee
Okay, there we go.
in class or employees, student in class.
Students in classes. Okay, I like that. Students in class, students in courses,
Yeah.
right? Students would be a table of students. Courses would be a table of courses. They're related, right? Because how many what courses are each student taking? There's a relation, right? So that's really what we're talking about. We're talking about a collection of fields and records until you get a database, and you can have each file or table related to the other. Okay, so just things to know. One kind of newer concept is the concept of big data, which is we continuously collect data. We're like Big Brother. If anyone read 1984 in high school, right? It's probably required reading nowadays, like it was in my day, and it always talked about collection of data. There's so much data being collected on every one of us, every moment of every day, that where is this data being stored, right? I mean, think about your transactions throughout the day. You take your cell phone, you turn it on in the morning, or maybe it's on all night long, right? Somewhere, some cell tower is recording its location and recording it in a log file somewhere, right? It's being recorded where you were all night long, right? Because every cell phone pretty much now has GPS, right? Now think about those records. Okay, you think about a day. How many pings does that cell phone make to the tower, right? Every single hour, every second. How many times? Who has that? Who has an iPhone? Anyone have an iPhone? I know some people. Most of you have Android phones, right? Because they're cheaper. And that's another good thing about Java, because Java is open source, makes the iPhones and the operating system cheaper. If I have a phone, is there a way you can track your friend in Android? Like on iPhone, there's an app called Find My Friends, right? Where I can literally share it with my location with somebody else, right?
Sure.
Okay, so imagine sharing a location all the time. I want to know where my wife is. She's pinging the tower. The tower's keeping track for her location, and every 30 seconds or so, it's going to re-ping the location the cell phone to know where she is. Where's that data being stored, people? Right? And not just us, but there are millions and millions of people all over the world that are using cell phones right now with GPS technology. So I'm just talking about one thing. Never mind your transactions you make with your cell phone, bits of email that are coming your way, texts, Snapchats, Facebook entries, every kind of thing you can think of that's coming into this through a radio channel, into your handheld computer. That's what this thing is, right? But everything's being recorded. Nothing's being lost. You can go back in Facebook how long, right? How long can you go back into your email? Where is that being stored? Somewhere. The concept of big data, and look what they say. According to IBM, approximately 2.5 quintillion bytes of data are created daily. 90% of the world's data was created in just the past 2 years because of the amount of devices we have today. Think about tomorrow when the Internet of Things kicks off, right? And we have devices inside of our bodies, right? You think it's a joke, but really it can happen tomorrow if we really wanted it to, right? Where we have links. Tomorrow, maybe there are not going to be any more cell phones. You might say, what? No cell phones? What, are you crazy? No cell phones, right? Tomorrow there's going to be Wi-Fi, ubiquitous Wi-Fi everywhere in the world, in every location, right? Why would you need a cell phone, right? Things will change. There'll be different ways of communicating than we have today. There'll be public links and private links that you can always have on with your family and friends. Think about those kind of things. Imagine if you're always on. Today you're always on, but imagine if you're really always on, and there's streaming information coming into your eyeball, right? At every second of every moment of every day, right? And into your ocular implant, or your into some kind of cochlear implant in your ear, right, and so on, or some kind of subdermal communication in your cheek. Where's all that data going? Forget about the crazy technology I'm talking about. I mean, it's got to go somewhere. The concept of big data, and it's only happening. It's only just starting to happen now. And how do we organize things? I know it's kind of I took a little bit of a sidebar there, but the idea of how do we measure this data, how do we store the data, and how do we access it. 3 levels of languages, just as a review. We have machine language levels, which is the bottom, very, very bottom level machine language. There's assembly languages, which is one level higher, and then there's higher level languages. And I would say probably naked C would be the bottom, like we kind of did this already. And then one step up would be probably something like a C++. Step up higher than that would be something like a Java. Step up higher than that would be a C#. Step up higher than that would be a JavaScript and Python. And we can keep going higher and higher as we spiral up the chain, right? But the higher you get, the farther away you get from machine language, the more compilation has to happen in order for that something to happen at the bottom end. Okay, think of it that way, right? So machine language, those zeros and ones, right, is what we want to happen, but we're compiling it at a very high level. Way back in the day, just as a review from a history lesson, right? That's how we did it, zeros and ones, right? It took forever to write a program, right? Now we could write programs faster, but they're much less efficient than they used to be. Now you might say, well, Tom, things run really quickly. Yeah, because our processors are improved. Our memory has expanded, all that kind of stuff, but we're lousy at writing programs. Our computers write the programs for us. And you know what? There's going to be someday another level of abstraction. We don't even do what we're doing today. Today's level of program writing is really, really low compared to what it's going to be 10 years from now. Imagine babies can write programs tomorrow. You might think that's crazy, and it probably is for us today, but tomorrow it may not be. Right? So just think about that. And the idea of where we sit from a Java perspective is very, very high. We're not at a machine language level for sure. So I'm going to skip through this. Just some interesting stuff. If you want to talk about the object model, and they talk about the automobile as an object. You guys should have seen this before, where the automobile can do different things. It has different properties. When we talked about classes and objects, you guys should already know this from C#. I'm not going to go over this again, nor am I going to test you on the automobile as an object, as a paradigm for the object here, or as a, I actually apologize for, because we've seen the automobile and the cookie as an object for very, very many times. The cookie can crumble, the cookie can be eaten, the cookie has properties, and so does the automobile. The automobile can be driven, it has color, you know, all this kind of stuff. It's the same idea for understanding classes and objects. We're not going to go there. One thing to note, though, is that Java is an object-oriented language first, from the get-go. Right, so if you think about Java as being something that you're learning, and you think you can do something like you do in JavaScript, where there's no structure whatsoever. You run a function and away you go. It's not how Java functions. It's not how C# functions. You have to encapsulate your functionality inside of a class, right? And that's how it works. We have a main class, and as we did our example, if I shift back to Eclipse, if you notice, we have a main class called Hello World. That's our class name, and it's encapsulating or containing this other public static void main function or method, right, that does these two things, that prints out these two statements, right? One with a \n escape sequence, and one with just a string literal. Okay, so again, it's encapsulated. The idea of instantiation is the same in Java as it is in C#. We learned about instantiation in C#. We have an object, our blueprint, right? Our class is a blueprint. We have an object. In order for it to get our car, we have a blueprint for the car. We want to make the car. We want to breathe life into the car. Oh, the car, right? That's how it happens in Java, right? Or in C#. We need our blueprint first, and we breathe life into the car. I like the teleporter idea, right? You know, I take Selena, she steps on the teleporter pad, right? We scan her, and then we teleport her somewhere else, right? Because she's the blueprint for all the other Selena clones we're going to have in the future, right? I'm just saying, right? So if we were to do that, right? Selena is the blueprint. She's the superclass, if you will, and or the main class, and all the other versions of Selena are instances of Selena, right? They're not the original. In fact, the original, the class itself, is just a blueprint, right? All the objects are instances of the class. Okay, that's the idea of instantiation. Again, we use object-oriented programming so we can reuse code. The idea of reuse, it was something that computer scientists were working on for a while. The biggest problem, and where you get metered, if you go working tomorrow, if you go to the bank, if you go to the government, whatever, one of the things you're going to be metered on is how much rework do you do, right? If you do a lot of rework at the government, you're not going to come back, all right? If you program and reprogram again and again the same code because you're not so good at it, not good, especially if you recode everything. You want to create a selection, a bunch of code that you're going to reuse, functional classes and algorithms that you're going to kind of have as part of your arsenal of code that you're going to kind of reuse again. And it's something that you're going to develop alongside your entire development team, right? Someone develops a module, someone else uses it. We're not going to rewrite that module unless we need to revise it, right? So think about that. Reuse is a big thing, and that's the reason why we use object-oriented programming. Okay, messages and method calls. This is an interesting one. This is slide 35 we're on right now if you want to handle along. If I use the car analogy, or let's use the teleporter again. I like the teleport analogy. When I when I teleport, the actual act of teleporting, moving from one place to the other, as an example, there's many things I got to do before I teleport, right? For me to create a teleporter, what do I need to do? Real life, right? I need to be able to scan the person at the molecular level. Can't do it right now. I'd kill them with radiation. They're dead, right? But tomorrow, maybe we can do that, right? Maybe we can scan them. So that's the first thing I do. So first I scan them. I take them into memory. That's the next thing. And the next thing I have to do with the teleporter is I've got to convert that person without killing them into energy, right? And then I got to transmit them somewhere else. Some station has to receive that person, right? Reintegrate them into the shape that they were before, not the other way around, not like they're insides out, like a bad Star Trek episode, right? And then, poof, you're there, right? You're back into normal. And it happens instantaneously. Well, for us, at the speed of light for others, right? So that's the way we teleport. All those things I'm talking about are encapsulated, are hidden inside the class. We don't want to know how it's done. We just want the teleporter to work, right? Just like we don't want to know how the engine works when we press the gas in the car. We just want the car to go, right? I don't need to know how much oil is being used every second, right? All I need to know is that my car is moving forward, right? So the same thing, we send messages in order for us to do this. When I make myself go forward, I send a message that says, I need to move forward. And that's usually through method calls. I call the method, I'm saying, hey, I need this part to work. The method responds saying, here I am. Here's my code that you've called for. Here's the functionality that you're asking for. Okay. The idea of attributes we talked about before, colors, the ability for the teleporter to do things is methods, and the idea of encapsulation and hiding, information hiding, is a big part of object-oriented design. Okay, you guys have known all this kind of stuff, and I'm not going to test you on it because you already know it. It's just a review from what we did in C# Programming 1 and Programming 2. Okay. Ilya killed me when I told him I was going to do this kind of stuff. He says, no, don't do it. They already know it. They know everything, right? They're experts. I said, okay. You guys also covered things like inheritance, where you have a subclass, or a, if you will, and a superclass, a class that is the progenitor. Like, for example, Selena, if I was going to take Selena and create clones of Selena, but that were different, like one clone that all she could do is mine, right? She's just a miner, Selena, right? So that's all she knows how to do, right? That's a subclass of the original Selena class, superclass, right? If I made another Selena that could fly because she had a jetpack, right? As an example, that would be a subclass of the first Selena superclass, right? Each of these other objects that I created from these other subclasses would be instances of the subclasses, but they would be related to the superclass, okay? The idea of inheritance, inheriting properties and methods, behaviors, if you will, from the superclass into the subclass. Okay, you guys know all about this. You guys are experts, right? And interfaces. The idea of interfaces, and this is one of the most confusing topics for students. When they look at it the first time, they're like, why do I need interfaces? I don't understand. Like, you know, and the reason for that is it kind of forces you into a structure. Think about the interface as the shape of a class, if you will. It shapes the class. It forces the class to include different behaviors and different properties. Just like when I create an abstract class, right? I create an abstract class. I create a shape of the class that I never want to actually instantiate, but I want to create other classes from it, right? An example of this would be animal. Does animal really tell us anything about the objects? There's lots of animals. Are we animals? Maybe, right? we're living beings. That might be a better superclass. So we're alive. That would be the first thing. A live being, something life, right? And the next, extraction or if extrapolation would be something like we're mammals, because we're not just animals. We have, there's things we have. We have fur. We have, we're warm-blooded and so on. And there's other kinds of beings that are alive that have cold blood, right? They all come from this life, but that's not really a class. It's an abstract idea of life. And we're extrapolating or we're abstracting away from it, right? And saying, hey, here's this more solid thing that we're talking about, this more realistic thing, this more contextual thing, this mammal. And further than mammal, one step lower than mammals is human being. Humans are different. They're mammals, but there's lots of different kind of mammals. Cats are mammals too, right? But we're very different from cats, right? Well, so you would think, right? Anyways, I digress. The idea of interfaces then and abstract classes gives the idea of the shape of the class as opposed to the actual class itself. Okay. And we're not going to talk too much about object-oriented design, nor are we going to talk about UML, right? But the idea should be there. Same thing with operating systems. Operating systems in general, you should know the main operating systems that we're working with. There are two types of operating systems primarily right now. Actually, let's say three types. There are desktop operating systems, right? There are mobile operating systems, and there are server-type operating systems, okay? Those are pretty much the operating systems that are out there. When I say mobile, I want to include smartwatches and wearables, okay? So for now, okay? Maybe that would be the fourth class. One day there'll be some kind of operating system in your eye, right? But for now, they're the main ones, right? So when we look at these operating systems, how does the type of operating system have an effect on how we program? Well, it has a big effect, because if I'm on a desktop, I'm going to program a lot differently than I would if I was programming on an Android phone, as an example, or a watch, right? That's a totally different thing. I have limitations. The smaller I go, the more limitations are up from a memory perspective, CPU capacity, blah, 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 for now, right? One day, you know what? My skin cell might be faster than my iPhone, right? But right for now, that's not true, right? One day, my tattoo that I have on my arm could be the computer that I have, right? It's not, my iPhone. I'm not limited to what I have. Right now, it's two-dimensional. Tomorrow, it could be three-dimensional, right? My computer. And that's going to affect the way we program. That's where I want you to take it from this, all right? Okay. Windows, of course, being the most proprietary operating system, this is where and the most common operating system in the world for now. This is where we do a lot of our programming. However, I'd like to mention that as we move forward, especially with open source, we're moving away from desktop systems and into more mobile systems that we're building. And that's why I think mobile development is so important these days. And the same concepts you're going to learn with Java. That's why when you learn Java, it opens up a world of different things you can do, right? Now, there is no mobile operating system so far you can build, or not so much with C#. Yes, you could Windows Phone, but do things with Windows. But it's not as popular as Java. Java, by far, and Android systems are more prevalent everywhere in the world than anything else. So when you learn Java, it opens up this whole world to you, right? I hope I sold it to you. Let's see. I'm going to talk to Android already. I've also talked programming languages at a very high level. I'm not going to talk about them again. All right. Whew. So way back in 1991, Java came out. Actually, it was around the same time where they were starting to develop something called JavaScript. And people got confused. Java and JavaScript. They're the same, right? No, they're very different. And people got confused. Why do they call JavaScript JavaScript? Well, because something called Java came out in 1991. Originally, it was called something like, I forget what, LiveScript. I think it was called something like that. It wasn't called JavaScript at all. And they took on JavaScript because of the popularity of Java, the programming language, which confused everybody, right? A couple things to note about Java in general. As the web exploded, there became other uses for Java. And like I said before, the biggest advantage of Java is the amount of application programming interfaces that exist for it. They have the most interfaces than any other language right now, okay? Which is hard to believe, but it's true. And there's different phases of JavaScript. This I will test you on. Okay, there's 5 phases when we're working with JavaScript. Editing, we edit the JavaScript somehow, or Java. I mean, I'm talking JavaScript. We compile, right? So we go from designing to actually compilation. What is compilation? Anybody remember from C#? What do we do when we compile? What do we do? We take it into bytecode. Exactly what we do. When we convert it into bytecode, once we move into bytecode or we move into a lower level language, right, we move it as close to machine code as possible so it does something. At the higher level, when it's in the editor, Java doesn't do anything. Neither does C#, neither does any of the other ones. It needs to be compiled. Then what we want to do is we want to verify that everything works. We want to skip through load and then finally execute the code once it's been verified. Now this all happens in a very quick way, right? 5 phases of Java development. Let's talk about these phases a little bit. Phase 1, in the editor program, you have your Java in the editor, right? It's saved onto disk. You have the .java extension for all your files, right? And there's different kinds of text editors we talked about before. If you want to, you can program in an editor. I talked about that this morning. You can go to Notepad++, Edit Plus, TextPad, JEdit. There's all kinds of other ones out there. I like Text Wrangler for the Mac. There's many, many different ones. The better way to do it, in my opinion, and I know there's haters, but it's the IDE, all right? Going with an integrated development environment where you have things like code hinting and IntelliSense on the Visual Studio side, right? It allows you to build stuff quickly, and this whole notion of rapid application development comes from using an IDE, something that's going to help you build. Now again, think about in the future what it's going to do. Half this stuff is going to be built for you, and all you're going to do is use templates and modify the templates to do something. You might think, well, that's not programming. Yeah, but that's where we're going to go, because the faster we can develop things and we can make functionality, the better it's going to be for all of us, right? And you know, the idea of software engineer 20 years from now may not be what we have today. Okay, just letting you know. Okay, so Eclipse, NetBeans, IntelliJ are kind of some of them, the ones that we use for IDEs. You can't really use Visual Studio for Java. I guess it's competing technologies, C# and Java, so Microsoft doesn't really create a very good environment for Java development. There are definitely things you can do with it. If you want to use it as an editor, you can still use Java as in Visual Studio. Okay. Phase 2, you compile the program. Once you compile the program, it changes into bytecode, and it's ready to execute, pretty much, right? And I'm not going to go too much into detail about the Java compiler, but the thing to note, and by the way, I'm not going to get you guys to do things at the command line level. I'm not going to go, hey, let's go into the command line and use Javac, the Java compiler, to compile code, because chances are, in most environments, you're going to use Eclipse or some other IDE to create your programs for you, okay? It's very rare that we go into the console these days unless you're programming something from scratch, and you need to do that because of the environment you're working in. But most companies don't do that for you, okay? Or don't do that to you is what I should say. Okay, so again, this idea of the Java compiler and this idea of using the JVM, which is part of the Java JDK, right? That creates a virtual machine for your program. All right, and when I say virtual machine, it's a small micro virtual machine that runs in the program environment that runs just for your little program when it's executed. Okay. One thing to note is that the bytecode instructions are platform independent because it's zeros and ones, right? And zeros and ones transforms to any platform, and that's another reason why when we compile stuff, we have compiled code, we can run it on any platform, right? Again, it's usually made for a particular piece of hardware, however, FYI, right? So you could take a Java program and run it on Linux or on Mac or on Windows or on Android or whatever. You just need to make some modifications to cater to the hardware and the operating system. We load a program into memory. And this is part of what the loading process, phase 3, we load the program into memory, and this is what happens when it's physically loaded in memory, we're ready to use it. And that's the idea of us having physical memory on our machines. Why do I have 16 gigs on my MacBook Pro? Is it because I just need it? No, it's because I have these programs that are running all at the same time in the background, and they're running in memory, in working memory, if you will, right? And there's different kinds of memory. Remember, there's storage, which is the hard drive, and there's active memory or working memory, which is what's running on my machine, right? at a very high level. Then we go into this verification process. We're verifying the bytecode that runs for our platform. And then finally, we execute our code. So those are the five phases of how we compile and execute. You need to know those things for the exam, at least in a multiple choice question, okay? The idea of this just-in-time compiler that compiles things when we need to and translates things into bytecodes is what the JVM is all about. Okay, I'm not going to go into too much detail beyond that for this one. We did a demo earlier today. We did this Hello World program, so I'm not going to touch that, and talked about the different pieces of Eclipse. I'm not going to talk about the internet and the World Wide Web. You guys probably know it better than I do because you use it every day. Sorry, let me take that back. Use it every second of every day, whether you know it or not, right? And let me go back to skipping through this piece. And that's it for this one. Internet of Things, I definitely mentioned that one. This is definitely something else that I will talk to on the exam. If I was going to ask you a question on the exam for Internet of Things, you should know what I mean. I mean like a transponder for paying tolls. Here's some good examples of the Internet of Things where Java can run. A heart monitor implanted in a human being. You know, Salinas transport, right? Technology that we're talking about here. This is the Internet of Things. A refrigerator that keeps track of your, you know, of the stuff that's in your refrigerator, how, what's ready to expire, and maybe you can even order stuff for you, right? You know, let's just take it to the next level. You've seen this stuff in the movies, right? And you're like, well, yeah, we've seen all this stuff before. Yeah. But there's things that people can imagine, like home automation, self-driving cars, self-cleaning robots for the home, and even things like things that'll clean you and take care of you when you're sleeping. I don't want to go into too much detail, right? Like sheets that are actually thinking, you know, like moderate your temperature, and clothes that you wear that change colors, and other kinds of things like that. There's unlimited technology that's out there, and we haven't even scratched the surface, right? It's all going to be done with something like Java. I think it's a great place to stop. We've had all kinds of glitches with our broadcast, and I need to take a break from a voice perspective before my voice stops. It's a great time to go to the washroom and do that kind of thing, and we'll turn back. We'll come back with part five of lesson 1. All right, so let's see if I can stop this thing without going crazy.